Now let's do some examples. Here we have to plot these points in a polar coordinate system, and so the first question is, the polar coordinates are given as this one 1 5 pi by 4. Remember, we mentioned the polar coordinates as r theta, where theta is the if it is positive, then now in the polar system you don't have this vertical line, okay, you only have the origin along with this single line, right? And theta represents this angle. If it is positive, then it is an anti-clockwise measurement, and r represents the distance from that particular point towards the origin. So when you have the polar coordinate as this one, that means from the origin you should have this axis, and then the angle will be 5 pi by 4. That means 5 times pi by 4. This is 2 pi by 4, this is 3 pi by 4, this is 4 pi by 4. Therefore 5 pi by 4 will be somewhere here, right? So this angle will be 5 pi by 4, and this distance will be 1 unit. So this will be the point that corresponds to this polar coordinate. Next question is 2 3 pi. So this is the polar coordinate. That means we should draw the line, and this is the origin or the pole. Now for the polar coordinate system, you call this as the pole, not the origin. Origin is for the Cartesian system, right? So we start from the pole, and the angle will be 3 times pi, right? So, and since this is positive, we should measure the angle in the anti-clockwise direction. So when you say 3 times pi, this will be 1 times pi. So if you say 2 pi, then it will come back to this starting point. And if it is 3 pi, then once again you will be at this stage, right? So it will be in this horizontal kind of line, right? Then since this is 3 pi, we have obtained the suitable angular position, right? So then we have to measure the distance from the origin, which is 2. Then we have to measure a distance of 2 units, and therefore this point will be the 2 3 pi point, right? Now this same point can also be represented with this angle, right? So instead of writing it as 2 3 pi, you can even write it as 2 pi, right? That will not make any difference, right? So now you can observe that there are so many ways to represent a single point, right? So you can keep on adding an angle of 2 pi, which you will eventually end up at the same point when you add an angle of 2 pi. So for all those values, it will give you the same position, right? So not like in the Cartesian system, here we have infinite number of representations to give the position of the same point, okay, right? And the next one is 2 negative 2 pi over 3. So now first we should mark the pole, which is 0 theta. Remember, you can you can represent any theta value if you like. For the origin, what the only requirement you need to have is the 0 at the first position, and you can write whatever the theta value you prefer. And then we have the straight line. Then here you have negative pi over 3, 2 pi over 3. So that means now 2 pi over 3 means 120 degrees, okay? But here it has a negative sign. That means we are measuring the angle in the clockwise direction. So you should measure that angle 2 pi over 3 in this clockwise direction, that is 120 degrees, and then you have to measure 2 units in here, right? 2 units in this direction. So this point will be the position, I mean the coordinate of this point will be 2 comma negative 2 pi over 3. And finally we have negative 3 pi by 4, right? So when you have negative 3, what we should do is, first we have to just disregard this negative and mark the coordinate of this point, which is 3 units, not in this direction. So 3 pi by 4 means 2 pi by 4 is 90 and 3 pi by 4 is somewhere in between, right? In between 180 and 90 degrees. So 3 pi by 4 measured in this direction, because it is positive, will be this angle, and the position of this coordinate will be here, right? But since the original question has a negative for the radius, what you have to do is you should find the right opposite point for this one. So you will get 3 units in this direction. So if we name this as P, we have the original point P in here, right? So it's like you don't have to mention, or you don't have to measure this whole angle, because you are just inverting this point. Now let's say if they have given, if they have originally given this one, right? Let's say if they have given 3 units, and how about this angle? This is 45. Now let's say if this is pi by 4, right? Suppose they have given the point like this, right? So then the original point will be, this is the horizontal axis. Then we have to measure an angle of pi by 4, that is 45 degrees in the clockwise direction with 3 units here, right? So this will be the point that corresponds to this one. And if they have asked to find another point with this one, what we have to do is, see, now the only difference is here you have positive 3, here you have negative 3. So what you have to do is you just have to take the kind of invert this original point, then you will get this one, right? So now what I want to emphasize here is that this negative radius can take place anywhere we need, but remember in those Cartesian system, negative means only in this direction, or in this, like if the x values are negative, then definitely it will have the point in this portion, and if the y values are negative, then definitely the points will be in this portion. But for the polar coordinate system, you don't have such a thing like that. It just invert whatever the point you have for the positive value, right? So if you have negative 3 along with this angle, you just have to write the same angle along with positive radius and then invert, right? And here also it was the same. See, you have negative 3 along with a certain angle, so you just have to write the same angle along with positive radius and just invert that point in order to get this required position.